Hi, my name is Melody. Today, I want to talk about theoretical yield and percent yield. Let's review first. What is theoretical yield and percent yield? The theoretical yield is the maximum possible mass of a product that can be made in a chemical reaction. Percent yield in chemistry is the ratio of the actual yield to the theoretical yield. The actual yield is the quantity of a product that is obtained from a chemical reaction. Here is a formula to how to calculate percent yield, which is actual yield divided by theoretical yield and then times 100%. Let's see some example. The first example is isolation of metal from ores. So, isolation of metals from ores. The original ores in nature are never pure substance, but always mixed with other metals. So, the mass of ores used to calculate the yield is not the mass of iron in the ores. So, the second example is the production of ammonia. Ammonia is produced by mixing hydrogen and nitrogen. However, this reaction is a reversible reaction. The amount of ammonia produced could be affected by several factors, which in practice cannot be perfectly controlled. So, why actual yield usually less than theoretical yield? There are a lot of reasons, but in usual, the actual yield is lower than the theoretical yield because three main reasons. The first is few reaction truly process too completely. And the second reason is not all the product in a reaction is recovered. And the last reason is reaction is a reversible reaction. So what is limited reagent and excess reagent? Here is the diagram to explain this. Make the hot dog and bun combine in a 1:1 ratio. We can make 4 complete hot dogs. However, once we run out of bun, we will have to stop making complete hot dog. In other words, the hot dog buns limited the number of complete hot dog we can produce. So how to use limiting reagent to calculate theoretical yield? Here is an example. A 3-gram sample of magnesium reacts with 5.15 sample of oxygen according to this equation. So here is the equation. 2 magnesium react with oxygen and produce 2 magnesium oxide. So how to solve this problem? To solve this problem, we first need to determine which reactant, magnesium or oxygen, is limited. We can do so by converting both reactant mass to moles and then using one or more mole ratio from the balance equation to identify the limiting reagent. From here, we can use the amount of limiting reactant to calculate the theoretical yield of magnesium oxide. In the first step, we need to converting the mass of magnesium and oxygen to moles using their mole mass. So here is the calculation of the mole mass of magnesium. And here is the calculation of mole mass of oxygen. So we use the mole ratio between magnesium and oxygen to determine how much oxygen we would need to fully consume, which is 1.23 times negative power of 10 mole of magnesium. Then we compare the answer to the amount of oxygen. We actually have to see if oxygen is limited or not. The number of mole of oxygen required to react with 1.23 times negative power of 10 mole of magnesium. Then in step 2, we find the limited reactant. Now we know the quantity of magnesium and oxygen in mole. We can determine which reactant is limited. So here is the calculation, which is 1.23 times negative power of 10 magnesium times the ratio of oxygen and magnesium. We get is 0.0615 mole of oxygen. So the ratio here is 1 and 2. Then, according to our early calculation, we have 1.61 times negative power of 10 of oxygen, which less than 0.0615 mole. This is mean oxygen is limited. So, how to calculate percent yield? Here is the example. A student mixed 25 ml of 0.314 BaCl2 with excess AgNO3, causing AgCl to participate. The equation for the reaction is here. Which is BaCl2 react with 2 AgNO3 and produce 2 AgCl with BaNO3. So, to determine the theoretical yield of AgCl, we first need to know how many mole of BaCl2 were consumed in the reaction. Now we have the quantity of BaCl2 in mole. We can find the theoretical yield of AgCl in grams. So here is the calculation of the molar mass of BaCl2. And then we use the molar mass of BaCl2 times the ratio, and then we get 2.25 gram. Finally, we use the equation which is percent yield equaled actual yield divided by theoretical yield and then times 100%, which is 1.82 AgCl divided by 2.25 AgCl and then times 100%. And then we get the answer is 80.9% in the finally answer. Here is the reference, and thanks for listening.